Welcome to Senior High School Math Series. Let us discuss about random sampling under statistics and probability. Here is our learning competency. At the end of this module, the learner will be able to illustrate random sampling. Before we continue, let us ponder on this. The city mayor would like to know the voice of City Hall employees regarding certain issues in the city. Since the City Hall has an estimated 1,700 employees, the mayor assigned one of his staff to select a sample of the employees and conduct a survey among these employees. In selecting employees, the staff might be a little careless in choosing respondents to the survey that will be conducted. Hence, the following questions arise. How many employees will he select as respondents? What is the most appropriate sample that he should get in order to get the real voice of the population of employees in the City Hall? How will he select the respondents to the survey? What is the most appropriate method in getting the respondents? This time, let us proceed to some definitions. In statistics, a population refers to the total set of observations that can be made. If a researcher is interested in studying the height of Filipino men aged 46 to 65 years, then the population is the set of heights of all Filipino men aged 46 to 65 years. If you are studying the general weighted average or GWA of students at the University of Caloocan City, then the population is the set of GWAs of all the students at the University of Caloocan City. This time, let us have sample. A sample is any subgroup of the population. A sample is used to obtain important information about a population for several reasons. First, it saves the researcher time and money. Next, it enables the researcher to get information that he or she might not be able to obtain otherwise. Also, it enables the researcher to get more detailed information about a particular subject. If a sample is to be taken from the population, the total number of population and the error tolerance level must be considered. For example, a research may be happy with a 95% confidence level. Then, a 5% error tolerance level must be considered. A higher confidence level of 98% would mean a 2% error tolerance. In this case, the Slovin's formula for determining the sample may be used. The Slovin's formula, sometimes written as Slovin's formula, was said to be formulated in 1960, and there's no clear information about who Slovin is. There's no clear nor elaborate discussion about how the formula was derived. However, the formula is given by N, or the sample size, is equal to capital letter N over 1 plus N times E squared. In here, capital letter N is the population, the small letter n is the number of samples needed, and E is the error tolerance level. The error tolerance level may be given in a question for finding the sample size, or if you are a researcher, you may figure out your own error tolerance. Just subtract the confidence level from 1. Let us have an example. Use the Slovin's formula to find the number of samples to be used by the mayor's staff, as mentioned in our introduction. If a survey is to be conducted among City Hall employees with a population of 1,700, use 5% error. Here is our suggested solution. From the information given, capital letter N, or the population, is 1,700, and we are asked to use the error tolerance level at 5%, so we have E is equal to 0.05. Substituting these values to the given Slovin's formula, we have small letter n, or that's the sample size, 1700 over 1 plus 1700 times 0.05 squared. We may use our calculator to evaluate. Then this is equal to 323.809. And since the sample size must be a positive integer, then we round this up to get 324. Therefore, the staff should use 324 as the sample size. Let us have another example. A student researcher would like to conduct a survey on the length of time a senior high school student in public schools in South Caloocan City spends on social media. According to the data gathered, there is a total of 4,274 senior high school students from 7 senior high schools in South Caloocan City during the first semester of school year 2020-2021. If the student researcher would like to have 98% confidence level for his survey, use the Slovin's formula to find the sample size. Here is our suggested solution. From the given information, the population is 4,274, and since we are using the confidence level at 98%, then subtracting 100% or 1 minus 0.98 gives us the error tolerance level at 0.02. Substituting these values to the Slovin's formula, we have sample size is equal to 4,274 over 1 plus 4,274 times 0.02 squared. You may use your calculator to verify. We will get n is equal to 1,577.355. And again, n must be a positive integer, so we round this off to 1,578. Therefore, the student researcher should use 1,578 senior high school students as sample. We usually use the Slovin's formula when we do not have any information about the population, or we do not know the behavior of the population. If the population standard deviation of the variable is known or has been estimated from a related previous study, the formula for the minimum sample size needed, that is derived from the maximum error of the estimate, is used. The formula is given by n is equal to, open close parenthesis, z sub alpha over 2 times population standard deviation over E squared. In here, n is the sample size. Z sub alpha over 2 is used in the general formula for confidence intervals. For a 90% confidence interval, z sub alpha over 2 is 1.65. For a 95% confidence interval, z sub alpha over 2 equals 1.96, and for a 99% confidence interval, z sub alpha over 2 equals 2.58. Solving for z sub alpha over 2 using other confidence interval will be discussed in the succeeding lessons. Although we have already started discussing about z value during the discussion on the normal random variables and the area under the normal curve. Lowercase sigma is the population standard deviation, and E is the maximum error of the estimate. Let us have an example. A student researcher wishes to estimate the average time spent in synchronous online sessions by senior high school students. How large should the sample be if he wants to be 99% confident that the estimate is accurate within 0.2 hours? In a previous study, the standard deviation of the time spent in synchronous online sessions by senior high school students is 1.5 hours. Here is our suggested solution. From the given information, the researcher would like to be 99% confident on the estimate, so z sub alpha over 2 is equal to 2.58 according to the previous discussion. E is equal to 0.2 since the student researcher would like to be accurate within 0.2 hours. And the population standard deviation from a previous study is 1.5 hours. Substituting these values to the formula to get the value of n, we have n is equal to open close parenthesis 2.58 times 1.5 over 0.2 squared. Using our scientific calculator, we have n is equal to 374.4225. Then we round this up to the next whole number to get n is equal to 375. Hence, the researcher needs 375 senior high school students as a sample. Next, let us have the law of large number. The larger the size of the sample, the more certain we can be sure that the sample mean will be a good estimate of the population mean. The law of large number implies that a smaller value for margin of error will result to a larger number of the sample size. This time, let us go to random sampling. A sample chosen is meant to be an unbiased representation of the total population. If for some reasons the sample does not represent the population, the variation is called a sampling error. To obtain unbiased sample, statisticians developed different methods of sampling techniques. First, we have the simple random sampling. A random sample is using methods such as random numbers, which are generated using computers, calculators, or tables. In random sampling, the basic requirement is that all samples in the sample size have an equal chance of being selected from a population. Let us have an example. In example number 2, let the error tolerance level be equal to 0.05. How many senior high school students in public schools in South Caloocan City should be included in the sample? Hence, show how the researcher will get his sample using simple random sampling. Here is our suggested solution. Since we do not know the population standard deviation nor any behavior of the population from a previous study, we will use, for the first step, the Slovin's formula to identify the needed sample size. From the given information, the population is 4,274 and the error tolerance level is 0.05. Hence, sample size is equal to 4,274 divided by 1 plus 4,274 times 0.05 squared. Using calculator or a scientific calculator to find the value for n, we have 365.768. Rounding this off to the next whole number, we get 366. For the next step, the researcher will get the list of all 4,274 senior high school students in public schools in South Caloocan City and assign a number to each student, such as 1 for student 1, 2 for student 2, 3 for student 3, and so on until student number 4,274. During the next step, the researcher will then write the numbers from 1 to 4,274 on pieces of paper of equal size. These pieces of paper will then be placed in an empty bowl or box. Without looking at the bowl or box, the researcher will then pick out 366 pieces of paper and identify the students who will be included in the sample. The researcher will then make a new list of students, this time for those who are included in the sample as respondents of the research. Random sampling has one limitation. If the population is extremely large, it is time-consuming to number and select the sample elements. The next method is the systematic random sampling. A sample is obtained by assigning a number to each element in the population and then selecting every kth number in the population. The value of k is the sampling interval, and it is given by k is equal to capital letter N divided by small letter n. In here, capital letter N is the number of elements or members in the population, and the small letter n is the sample size. Let us have an example. Show how systematic random sampling may be used in identifying the respondents of the study in example 4. Here is our suggested solution. From the given information, the population of the study is 4,274, while the sample size as determined using the Slovin's formula is 366. Hence, if systematic random sampling is to be used, the value of k must be identified. From the formula, we have k is equal to 4,274 over 366. Using a scientific calculator, we'll get k is equal to 11.6776, and rounding this off to the next whole number, we have k is equal to 12. So the sampling interval must be an integer, then we will use k equals 12. For the next step, the researcher then will list the students in the population from 1 to 4,274 and randomly determine the starting number where the sample will be identified. For example, the researcher will start with student number 5. So we have the list as student 1, student 2, student 3. The pattern continues until student number 4,274. The researcher will then select every 12 students from student number 5. Hence, the sample will include students 5, 17, 29, 41, until 4,265. However, student number 4,265 is only the 355th sample in the group. Since the researcher needs 366 members in the sample, so the researcher will go back to the beginning of the list and continue. This is now called a repeated systematic random sampling. In systematic random sampling, the advantage is in the ease of selecting members of the sample. In many cases, a numbered list of the population already exists. For example, an enrollment officer from the Division of City Schools may already have a list of students enrolled in junior high school or senior high school. Also, a manager of a company of interest in a study may already have a list of employees or staff. In using the systematic random sampling technique, the researcher must be careful on how individuals or items are arranged on the list. For example, if each unit were arranged, let's say, as number 1 male, number 2 female, number 3 male, number 4 is a female, and so on, then the selection of the starting number could produce a sample that contains all male or all females in the sample or in the list of respondents. This time, let us have the stratified random sampling. A sample is obtained by dividing the population into subgroups called strata, according to various homogeneous characteristics, and then selecting members from each stratum for the sample. Let us have an example. The guidance counselor of the school would like to determine whether 1,200 junior high school students prefer a specific strand over other strands in senior high school. How is he going to choose a sample of 300 students using stratified random sampling if there are 160, 180, 208, 244, 220, and 188 students in each stratum? Here is our suggested solution. In a table, organize the students according to stratification with their corresponding number. On the first column, we have the stratification, and then on the second column, the number of students per strata. The total number of students, or the population, is 1,200. Next, to obtain the sample size per strata, divide the number of students in each strata by the total number of students. Then, multiply the result by the desired sample size. In this case, by 300. Let us have, for example, the first strata. The number of students in the first strata is 160. So, 160 over 1,200 multiplied by 300, and that gives us 40. 40 students will be obtained from the first strata. The pattern continues until the last strata, until we get the sample size of 300. The advantage of using stratification or the stratified random sampling is that the researcher is able to ensure that population subgroups that are important in the study are well represented. However, a disadvantage occurs if there are many variables of interest in the study. Dividing a large population into representative subgroups would require a great deal of effort, and if the variables are somewhat complex or ambiguous, say for example prejudices, attitudes, and beliefs, it is somewhat difficult to separate individuals into the subgroups to these variables. This time, let us have cluster sampling. In cluster or area sampling, the sample is obtained by selecting pre-existing natural group called cluster and using the members in the cluster for the sample. Let us have an example. Medical researchers would like to conduct a certain study among COVID-19 patients admitted in the different hospitals in Caloocan City. What is the most appropriate method of sampling, and how are they going to do this? Here is our suggested solution. Since the different hospitals in the city is considered a pre-existing natural group or cluster, the most appropriate sampling technique is the cluster sampling technique. For the first step, after identifying the sample size, divide the population into clusters and use the different hospitals in the city as clusters. Since not all patients admitted in the different hospitals will be included in the sample from each cluster or hospital may be identified using the simple random sampling. The advantages of using the cluster or area sampling technique are: number 1, cluster sampling can reduce the cost. Number 2, cluster sampling can simplify the fieldwork, and it is convenient since the researcher need not wait long nor travel far to get from one respondent to another. The main disadvantage of using the cluster or area sampling technique is that the members in a cluster may not have the same variations in characteristics as the members selected individually from a population because of the homogeneity of people from the same clusters. That will be all. Thank you for watching. Please subscribe for more math lessons.